Revision for topic 9, differentiation. This topic will also ask in section A and also section B. So these are the type of question that will be asked in section A, such as the first principle and also finding the differentiation. So look at revision set 1, question 2. The first question, it asks you to find the derivative of fx using the first principle. So you cannot do the differentiation directly. You must use the first principle formula. So your limit must be very strong so that you can simplify to get the answer. So this is the first principle formula, which it involves fx plus h minus fx over h for limit h goes to 0. The first principle formula is the same for any value of fx. The second one, it asks you to find the differentiation of sine ln 3x. You can differentiate directly because differentiation of sine will give you cos and the angle is the same, but you have to multiply with the differentiation inside the angle, which is 3 over 3x. It can be simplified to 1 over x, so that's why the answer is cos ln 3x over x. The second one, you must use the quotient rule for x over x cubed plus 1 and also a product rule for e to the power of 2x tangent x. So this is how you do it, the quotient rule and also the product rule, combining the answer and simplify. Revision set 2 also asks you similar question, which to find the differentiation of ln and also tangent. So you can differentiate directly ln, which is 1 over fx multiply with the differentiation of your fx, which is sine. Differentiate, you will get cos. The angle is the same. And why we multiply with -2? Because the differentiation of its angle. Simplify your answer, then you will get something like this. Tangent e to the power of 2x. Please don't do any product rule here because it does not involve two different things. It's just one single thing, which is tangent, and its angle is e to the power of 2x. So differentiation of tangent is secant squared. The angle is the same, but we have to multiply with the differentiation of its angle, which is 2e to x, and that is your answer. The second one is also a direct differentiation. You don't have to use any product rule. This is just a direct product. This is just a direct rule of differentiation where the power you bring to the front and then its power just now reduced to 4, and then we multiply with the differentiation inside the bracket, which is 2x. So you get the value like this here, but it asks you to evaluate, meaning that you have to give the value for dy dx when x equals to -1. Substituting x equals to -1, you will get dy dx in terms of a number, which is -160. Also similar question for revision set 3. For the first one, is just tangent cube. Don't use any product rule here because it's just one single term, just that tangent is to the power of 3. So that is why we have to bring 3 to the front. The power will be less 1, which is tangent squared. The angle is the same, but then we have to differentiate inside the bracket, which is tangent just now. Its differentiation is secant squared. Ex plus 3, the angle is the same. But why we have to multiply with ex? Because the differentiation inside the angle. So there are three layers of differentiation for this question, but don't use any product rule because it does not involve any two different things. It's just one single trigonometric function. The second one is also a long question, which you can use the logarithm rules to simplify your function first before you differentiate. So when you simplify your function, it's easier for you to differentiate separately. And the next one is also an exponential function, which you don't have to use any product rule or quotient rule because it just involves one single function here. So differentiating an exponential function, you just copy back and then you multiply with the differentiation of its power. So here is the differentiation of its power, which you have to solve using product rule and simplify your answer. Your working will be more than this, I guess, but this is just the simplified version of the working. There are many layers of doing this, so be careful with your differentiation working. As I said, topic 9 will be asked in section A and also section B. Section A is like just now, where you have to find the differentiation of the function, whether in ln, trigo, or a second order differentiation or third order of differentiation. But in section B, it will ask you about implicit differentiation and also parametric differentiation. So for question set 1, section B question 6, the first question 6a, it asks you about the parametric equation of a curve. So it asks you to show, and then you just use the parametric formula to get the answer. And also the second one, it asks you to find the second differentiation of that parametric equation. You have to remember the formula. This is the formula for d squared y over dx squared for parametric. Make sure all your working is correct from the previous one, then you will definitely will get the answer. You will tend to do more careless mistake here because it involves many differentiation, but be careful with all your notation. And remember, these are the passive question. And these are also the clone question that it will come up in your exam in just a couple of days later. Okay, the second question, 6b, is asked about the implicit differentiation where it involves y and x in one same function. So what you need to do in the first one is this is just an exponential function. You just copy back and multiply with its differentiation. But remember to put dy dx because we are differentiating y. 2xy, you must use the product rule, and ln 1 minus 2x, you can just differentiate directly. 2, you differentiate, you will get 0. And then you don't have to simplify the answer to get dy dx because the question asks you to calculate the value. So the value of dy dx when x equals to 2 and y equals to 0, you can substitute them before you simplify your dy dx. It's easier. Then you will get dy dx equals to negative 1 over 3. Why I don't recommend you to simplify dy dx first? Because you will tend to do more careless mistake when you try to simplify dy dx first as your subject. Then you substitute the value. You can always directly substitute the value first before you simplify dy dx because at the end of the day, you will definitely get the value for dy dx, not dy dx in terms of x and y. Set 2 also asks a similar question, which the first one, it asks you to find the parametric equation of a curve. it gives you the value of x and y. So you have to use the formula for parametric equation to find the dy dx. And then you can also find its d squared y over dx squared using the formula. But in this case, even if you don't simplify them, you can substitute t equals to square root 3 to get your answer. Since the previous question for set 2 is asked about the parametric differentiation, so the next question, 6b, will ask you about the implicit differentiation. So implicit differentiation here for 3x squared plus y squared equals to 4y, you can differentiate directly and implicitly. And then as I said, it asks you to find the value, meaning that for a certain point, which is x equals to 1 and y equals to 3, you can substitute the value to get your dy dx. And also, you have to differentiate again for minus 2y, or if you like 6x plus 2y dy dx equals to 4 dy dx. You have to differentiate again to get your answer for d squared y over dx squared. Or you can also differentiate 3x over 2 minus y using the quotient rule. You will definitely get the same answer, whether to use this one to differentiate again or to use this one to differentiate again. The difference between them is just this one is the simplified version of dy dx. This one is not the simplified version of dy dx, but you can also differentiate from there to get the value of d squared y over dx squared, which is the second order of the implicit differentiation. Again, for set 3, we ask you the first one, the implicit differentiation for x squared equals to 2x minus y squared. So xy you can differentiate using the product rule, and 2x minus y you can differentiate directly because 2 can be bring to the front, x minus y can be differentiated with x equals to 1 and y equals to dy dx. And you can substitute directly the value x equals to 1 and y equals to half to get the value of your dy dx. And also again, you have to differentiate for the second time and substituting the value to get your d squared y over dx squared. As I said, you don't have to simplify your answer here to get d squared y over dx squared, because the question does not ask you d squared y over dx squared in terms of x and y. It asks for the value. So you can always substitute first the value of x equals to 1, y equals to half, dy dx equals to half, because it's easier to deal with number than the unknown. And similarly, with the previous set, you will be asked about the parametric equation. So again, this question is asked about the parametric equation, but just the different function is used here. We are going to use x equals to cos 2t and y equals to 2t plus sin squared t. You have to be very careful with your working. Please avoid careless mistake, then you will definitely get the answer as what they want. So that is all for topic 9. Remember the first section, section A, it will ask you about the differentiation of y and also the first principle. So please remember the first principle formula. And for the section B, it will ask about the implicit differentiation and also parametric differentiation. The working are there, you know how to do it. It's just that you need more exercise on doing it. So I hope you can get the optimum mark for this topic 9.